All right, factoring. So the first one, okay, we've got a leading coefficient of 1, so I know it's going to be pretty simple. It's going to add and multiply. I'm going to start out, we've got a trinomial. I've scanned it already and said, okay, no GCF, so that's why I start with my two sets of parentheses. So I know it's x and x. I need two numbers that are going to add to -5 but multiply to -36. So in my mind, I'm thinking -9, +4. That's all they're asking you to do there is factor. There is no equal sign, so it's not asking you to solve. You stop right there. That's your final answer. The next one, same idea. Leading coefficient is 1. There's no GCF, so I'm going to go to the add and multiply. So B, I notice both signs are the same, so they're both going to end up being positive. So I know it's B plus 2 and B plus 2. You could write that as B plus 2 quantity squared, but you don't have to, but know that you could see it expressed that way. In number 3, I've got a leading coefficient of -1. So in order to make my life a little bit easier, I would factor out that -1. Treat it as a GCF. So now I've got z squared plus 15z plus 56. Now factor the trinomial that's inside the parentheses. Don't forget about your GCF there, -1, and now I'm still thinking add multiply. So I'm going to go with +8 and +7. That's going to be my final answer for number 4. Or number 3. Number 4, I've got a leading coefficient here of 4. So it's going to be a little bit more difficult. There is no GCF there, but I still can figure this out. 4 is not a prime number, but my constant is prime, so I do know that I'm going to have a +2 and a +1. All the signs are plus, so I know I'm going to have positive. Now I've got to decide, am I going to put 4a in A, or am I going to put 2a in 2a? Well, think about what we talked about when we were talking about factoring. I talked about that smart factoring, or smart guessing. If I put the 2a there and I wrote it in red, what's happening in that first set of parentheses? Right, because there's a GCF there. So you don't want that to happen. So automatically I would say, don't put the 2 there, okay, because then you've got a GCF. So now, I know my factors are going to be 4a and a. Again, I'm not going to put 4a there because I'm going to end up with another GCF. So I'm going to put 4a and a. Now just double check. Okay, double distribute and see if it does come out to be this trinomial. So that's going to give me 4a squared. I've got 1a plus 8a. Bingo. That gives me 9a, and then 2 times 1 gives me 2. I'm good. Okay? Good so far? Yes? Okay. All right. Go ahead and let's take a look at number 5. Leading coefficient is 2, but it's prime. There's no GCF. So I'm going to start, I'm going to say 2x and x. But my constant is -12. So I've got some factors to think about there. Okay, I've got 1 and 12, 2 and 6, 3 and 4. Where do I want to place some things? I know I'm not going to put something with this first set of parentheses that's going to have a GCF of 2. I'm not going to put the 12 there, or a 6, or a 2, or 4. What should I put with that then? 3. 3 here, 4 there. What should my signs be? Now, when I combine, I've got to end up with a +5. So I'm probably going to say that's going to give me a +8x. And then a -3x is going to give me that +5x. All right, number 6. A little bit more challenging because this is not prime and neither is my constant. Give it a try. What do we think? notice about 9 and what do you notice about 4, other than they're not prime numbers? What kind of numbers are they? 9 and 4. They're perfect squares. Okay, 9 is a perfect square. Square root of 9 is 3. 4 is a perfect square. Square root of 4 is 2. Maybe we're on to something here. Let's try. What if we had 3c, 3c, 2, and 2? We've got to multiply to a positive, but add to a negative. So, negative, negative, let's see. Does that, if we double distribute, does that give us that trinomial back again? So I get negative 6c, and negative 6c gives me a negative 12c. There's my winner. Right? So I could write that as 3c minus 2 quantity squared. Number 7. What do we see in number 7? Simon. Yeah, the GCF of what? 3. So I get 2x squared minus 5x minus 12. So I took out a GCF, and now I would take that trinomial. And can that be factored further? 2x and x. It's that same idea. Very similar to number 5, where we're at right now. So maybe the 3 and the 4, but I've got to combine to get a negative 5. So where am I going to put my negative and where am I going to put my positive? I'm going to have a negative 4 and a positive 3. Okay.
Diego del Toro.
Number 8.
47, please.
GCF of 3. A squared minus 9a plus 20. Are we good? Okay. Can this be factored further? Can we come up with two numbers that add to negative 9 and multiply to positive 20? 5 and 4. And where the signs have to be? Negative, negative? Yeah. Okay. Alright. Take a look over here to number 9. 2 rectangles. Area of the shaded region. So if they asked us for the area of the shaded region, we'd have to find the area of the big rectangle, and then the area of the small rectangle, and then do what to those two areas? Okay, so we need to take out that white area to be left with the area of the shaded region. So we could say the area of the big rectangle, length times width, minus the area of the small rectangle, which is just 1 times 3 or 3. And I'd say x squared. I'm going to combine these inners and outers in my head here, so 3x and 5x. I'm going to go right to 8x plus 15 minus 3. And then, so my area of my shaded region is going to be x squared plus 8x plus 12. Sorry about that. I got a little squeezed in there. All right, 2 circles. Same idea. Find the area of the big one, the area of the small one, and then subtract the 2. Who knows the area formula for a circle? Who remembers that? Kind of square. Yeah. Okay. So the area of the big one, its radius, okay, is r. So the area of the large rectangle is just that, pi r squared. You're telling us the radius of large one is r. And then take away the area of a small circle, which is pi, and what's its radius? 3 squared. So now I've got pi r squared minus, are we okay with that? 9 pi? Just 3 squared to get 9 pi. What do these two terms share in common right now? They share a GCF. Pi. So now watch what happens. This one's kind of cool. So we take out that common factor of pi and we're left with r squared minus 9. Is r squared minus 9 look at all familiar? Difference of perfect squares. Okay? So this, my friends, we can factor again. So we end up with pi, r squared minus 9 factors into r plus 3, r minus 3. Okay? So difference of perfect squares right here. So my final answer would have to be that right there. Okay? Two squares. So area of the large one. So if we know it's a square, we know that all sides are x plus 1 minus the area of that small square. Sean? If it didn't say factor completely, then you probably could leave it, yeah. So we end up with x squared. Again, I'm going to combine to get that middle term. It's 1x and 1x to give me 2x plus 1 and then minus 4. And then simplifying x squared plus 2x minus 3. Good? All right, we'll do one more. We'll do the triangle. Right? Two triangles. Difference in area. So again, we're still doing the same idea. We're going to find the area of the large one, subtract the area of the small one. So area formula for a triangle: 1/2 base times height, or base times height divided by 2. However you think about that, it's okay. So, we don't even need to do that. They gave us the areas. It was making it harder than it is. Okay. Just we've got to subtract our two areas. So 3x squared plus 12x minus, be careful, put the area of that smaller one in parentheses because you're subtracting that area. The area is 2x plus 8. You've got to make sure you subtract that whole thing. That's why I had to put that in parentheses, because when you put it in parentheses, you have to remember to distribute what? -1. Okay. So 3x squared plus 12x minus 2x minus 8. Now we can combine like terms. 3x squared plus 10x minus 8. Good? Good. Alright. I'll let you guys look at 13 on your own time. Let's go over to some completing the square. These are fabulous. Completing the square is probably one of my faves, but it's difficult because there's a lot of steps, so therefore a lot of opportunity to make mistakes. Okay? So if I want to complete the square, let's look at this one. Is it, this first question, is it ideal to complete the square? I know the question told us to complete the square, but is it in a form that's ideal for completing the square? So when is it ideal to complete the square? When the a is what? 1. That makes our life easy. We can complete the square when the a is something other than 1. It's just going to be a little bit more difficult. So a is 1, and what do we want b to be? Jackson. Yeah, we want it to be an even number. Okay, because we're going to divide it by 2 and square it. So if we take an odd number, divide it by 2, we're going to end up with a fraction, and fractions just can get a little messy sometimes. So this is in a good form here. So I start out x squared plus 2x. I give that constant a shove to give myself some space there so I can start to make my perfect square trinomial. So now my b is 2, so I'm going to take half of b and square it, so that gives me 1. So I say x squared plus 2x. I add 1 and subtract 1. Minus 15 equals equals 0. And I'm doing that so I can set up that perfect square trinomial now. And I can factor it. Easy. You don't have to show that work. Nope. I just always do so everybody sees it and knows what's going on. Okay? So this perfect square trinomial is going to be x plus 1 quantity squared, meaning x plus 1 times x plus 1. Combined like terms, minus 16 equals 0. Because it's equal to 0, they're asking us to solve it here. So we're going to add 16 to both sides. Because in order to solve it, we need to isolate x. Well, x is tucked inside those parentheses. So in order to start to get stuff away from that, we've got to add 16 first. Now I can take the square root. Because what's being squared is now isolated. That's when I can take the square root. So I've got x plus, oops, I don't need the parentheses anymore. I've got x plus 1 equals, but when I take the square root in an equation, I've got to remember plus and minus 4. Now I have x plus 4 equals positive 4, and x plus 1 equals positive 4, and x plus 1 equals negative 4. This is going to give me my two roots, or my two solutions. So if I subtract 1 from both sides, I get x is positive 3, subtract 1, and get x is negative 5. Okay, so those are my two solutions. I could represent those two solutions in curly brackets, least to greatest, negative 5, 3. Do not put those in parentheses. That would look like a point, or it would look like interval notation. If you wanted to list them together, they'd have to be curly brackets, but this is still totally acceptable to leave your comments with that. All right. We'll do one more completing the square. Let's jump down to number 3. So in number 3, shove the constant over, and now take half of b and square it. So that gives me negative 3 squared, which is 9. So plus 9 minus 9 minus 1 equals 0. Go ahead and factor that trinomial. That's going to be x minus 3 squared minus 10. I'm going to add 10 to both sides. X minus 3 squared equals 10. Now I can take the square root. Plus and minus square root 10. Okay. Add 3. X is equal to 3 plus and minus the square root of 10. That's all you can do with that. Okay, square root of 10, that's an irrational number. Leave it. It doesn't simplify. You're good. It's standard form to put that rational number in front of the plus and minus. Okay, standard form to write that first. Okay. All right, let's hop over. Let's do a couple quadratic formula questions, and then we'll be done. Izzy.
Like, this is something to square by changing it to vertex form. So where would you just stop before you actually complete it?
Oh, is that all it asked us to do? Just put it in vertex form?
That was one of the questions I was
Oh, so vertex form, if they just asked you to complete the, that's it right there. There's your vertex form. Yeah. Okay. Anything else? Brendan?
If they wanted you to, if they left it in the rational number, put it in dash form, or would you solve it to the nearest?
Only if it asks you. If it asks you to the nearest 10th, nearest 100th, go to your calculator. If not, leave it in radical form because that's the exact answer. Because there was no rounding that occurred. What else? Questions? Okay. All right, quad formula. Okay, this is given to you on your formula sheet. Okay, now everything that I give to you, okay, I include a formula sheet. You guys have seen it. Okay, quadratic formula is there, it will be there the day of the test. So x equals negative b.
Attention, will modify the cross. Our bus will be leaving at 3:10. We need to be at the back gym and ready to go at 3:10. Thank you.
Anybody who's cross will be done in like 5 minutes. Okay? Alright, so there's the quad formula. So let's see. Let's do number 2. So my equation m squared equals 20 minus 4m. You have to put this in standard form and set it equal to 0 before you can use the quadratic formula, because you need to find the a, the b, and the c. So you must have, make a little note, standard form equal to 0 before you can use the quadratic formula. I would, just to make life easier, try to make your quadratic term, your squared term, positive. So I'm going to move the 20 and the negative 4 over to the left. So m squared plus 4m minus 20 equals 0. Just rewrote it, set it equal to 0. That's all I did. We good? Okay. Now I can list out my a is 1. That's my leading coefficient. B is the coefficient to the linear term, so that's 4. And C is the caboose, C is the constant. Okay. Once I list them out, and guys, you don't have to do this, but this is good work to show. Because when you're using the quadratic formula on the test, write everything down. Okay? It's amazing how smart you are when you give your eyes stuff to look at. When you try to do too much in your head, you're going to make a mistake. Tyler.
Is your quadratic on the readings every year?
That I can't predict. Some things, there's a couple things I can predict. Not this one, I can't. I haven't seen enough of it occur to say, yes, it will definitely be there. We're good? Okay. X equals. So now I just go and I start to substitute. So negative 4 plus or minus square root b squared. I don't do any of this calculation in my brain. None. Just substitute. We're going to let the calculator do all the heavy lifting. Okay? Minus 4 times a times negative 20. All divided by 2 times 1. Showed my substitution. Now I'm going to go right to my calculator. So I'm going to go to the calculator for this. Right there. Not the square root. Don't start with square root. Just what I highlighted. So in your calculator right now, type in 4 squared minus 4 times 1 times negative 20. And what do we get? I see 16 plus 80, which is what? 96. So now I'm back on my paper and I'm going to say negative 4 plus or minus the square root of 96 divided by 2. Now I'm going to pause and I'm going to look at my choices. Okay, I don't see anything that looks just like that right now. Now, what I would do is, okay, this just needs to be simplified. So we end up with, I'm running out of space, negative 4 plus or minus, let's think about 96. Think about some factors of 96, and one of them is a perfect square. What two numbers multiply to 96, and one of them is a perfect square? That's it. 6 and 16. So, does 6 times 16 give us 96? Yes. And is 16 a perfect square? Meaning, can you take the square root of 16 and get what? Okay, watch. 16 times 6. All divided by, I'm going to move this because I'm running out of space there. That's not good. So, I'm just going to rewrite. 16 times 6, and that's all divided by that 2. So, what is the square root of 16? 4. I change colors. I'm going to put that 4 out there. Good so far? And then, believe me, I'll address desperation mode in a second, okay? Because probably some of you are freaking out with this simplifying, and that's okay. negative 4 plus or minus 4 square root 6 all divided by 2. Now I can simplify my fraction. What do they all share in common? 2. So if I take negative 4 and divide it by my GCF, I end up with negative 2 plus or minus. Now it's just the 4 that you're dividing by that GCF, not the square root of 6. Okay? So when I take that 4 and divide it by my GCF, I get 2 square root 6, and 2 in the denominator divided by 2 just gives me 1, which then, finally, after all that, I go and I pick choice 2. So now, desperation mode. You get to here, and you're like, that's all I know how to do right now. And it's multiple choice. What could you do to help you select the correct choice if you got this far? Sean? Okay? In your calculator, type in negative 4 plus the square root of 96 divided by 2. Get some crazy decimal. Then type in negative 4 minus the square root of 96 divided by 2. Get another crazy decimal. And then do the same thing with the choices till your crazy decimals match the choice. And that's the one that you pick. Okay? Simplifying radicals, which we did right here. Okay? This little piece right there, that is not part of the curriculum. It's okay that we didn't know how to do it. They will not test you on that. Okay? They will not test you on simplifying radicals. Okay? So that's something a little extra that we just talked about. Done.
You also said that
Oh, yeah. Awesome. Okay, what Sean said, he said take this, okay, this initial, and set it equal to each choice, and then see if they equal each other. You can't use the plus or minus at the same time. You got to do it separate because there isn't a plus minus button. Okay. Let's see. Maybe one more. Are we good? Want to do one more? Yes? Good. Number 5. Let's do that. What do you think we need to do with that equation first? Jackson? Yes. So we end up with 9x squared plus 3x equals 2. Now what do I have to do? If it tells me to solve it by the quadratic formula. Subtract 2. Because remember, I've got to get it in standard form set equal to 0. Now they're forcing us to use the quadratic formula here. Chances are this probably could be factored. Okay, but they're forcing us, and that's what we're practicing right now, is quadratic formula. So I'd list A is 9, B is 3, C is negative 2. Go ahead and X equals negative B plus or minus, B squared, remember we're just doing substitution, B squared minus 4 times A times C all over 2A. So let's see, minus 4 times A times, just checking. Yep, we're good. Go to your calculator. 3 plus or minus. Enter that. 3 squared minus 4 times 9 times negative 2. We get 9 plus 72. Yes? 81? 81. Yes, 9 plus 72, 81. Whoops. Can't write in highlighter. Ooh, that's nice. Why do I say that? 81 is a perfect square. Okay. Got a nice rational number there instead of an irrational number, which tends to make things a little messy. Negative 3 plus or minus 9 over 18. Now let's break that up into our two solutions. Negative 3 plus 9 over 18, and negative 3 minus 9 over 18. So in the top one we get 6 over 18, which simplifies to 1/3. There's one of my solutions. And then negative 3 minus 9 is negative 12 over 18, which simplifies to negative 12 over 18 simplifies to negative 2/3. So it is choice number,
Beautiful.
all done.